Hello everyone, welcome back to our college algebra course. Today I'm going to be talking about the last two sections of our course. It's section 6.7 and 6.8. They're all about some applications involving the log function and the exponential function. So in 6.7 we're going to be talking about some financial models, the application involving money. Okay? So 6.7, financial models. The first formula that you guys are going to see today is the simple interest formula. Formula says this: the interest is calculated by P times R times T. First of all, let me box that. Where P is the principal, R is the rate, and T is the time. Of course, I stand for the interest. So basically, what the formula saying is this: P here is how much money you have for now, and you want to invest that money, that amount of money, with the interest rate of R amount of time T. Then you multiply the three quantities together, you will get the interest. Okay. So in reality, our currency is US dollar, so P is in US dollar. That's the unit, and the rate. In reality, for now, we use the annual rate. So rate per year. Whenever you see APR, I think annual percentage rates. It's rate per year, and of course the unit of the time gonna match it with the unit of the rate. The rate is per year, so the unit for the time gonna be year. So I think let me give you an example. See it. Say somebody have $1,000 for now, okay, and that person want to invest in the rate R of 12%, and with the time T of 3 years. Question: how much money is that person going to have after 3 years using the simple interest formula? Then the interest after 3 years will be P times R times T is going to be 1,000 times R. Right here, be careful, guys. When we talk to each other, we use percentage for the interest. However, when we do math, we gotta convert that percentage back to decimal. So 12% is equivalent to 0.12. Right? It's 12%. And 3 years, you match up, so times 3. And the interest after 3 years, $360. That's the amount of money that we got after 3 years. And keep in mind that in this formula for simple interest, because the interest is calculated based solely on the principal amount. Okay? It means what? 12 years is 12% right here. I mean, not 12 years, 12% right here. Each year you're going to earn the same amount of interest. 3 years, 360. Each year, 12% of 1,000 is $120. So simply calculate it. Every year you're going to earn $120. That's all. That's what they call a simple interest. However, keep in mind that $120 that you earn this year, the value of it may not be the same as the value of $120 that you will earn next year. Okay? And that's simple interest formula. Now, if you want to calculate your future amount after 3 years, all you have to do is what? Add the interest to the, this is the principal, to the interest. So after 3 years, the interest that you earn is $360, but you don't lose your $1,000. Even though I claim the value of $1,000 now, and 3 years later it may not be the same. Okay, it not was the same. But just looking at the number after 3 years, your future amount AT is equal to P plus I. Okay, A here is the future amount. So okay, T is represent the time, and then how you calculate that amount? You take the principal plus the interest. Okay, so in this our particular problem, A3, the amount after 3 years is 1,000 plus 360, which is $1,360. Okay. Oh, actually, I just gave you a formula right here, so let me box it. Okay. All right. Now let's move on to other formulas in this section. Number 2, compound interest formula. Compound interest. Okay. So, say you don't like that, I don't want to get my interest using the simple interest formula. I don't want to wait until the end of the year to get 12%. I want to, instead of having 12% a year, I want to break it up into monthly. So I want to have like 1% a year. I'm sorry, 1% a month. So add up 12% a year. And you know the advantage of that, say you used to have $1,000, right? You want to have 1% a month. So after 1 month, you're going to earn 1% of interest instead of waiting until the end of the year to get 12% total. 1% for the first month, and then you got some interest. You want to add the interest back to the principal amount. So after the first month, you gain a little bit more money from the 1% of interest, okay? And then for the second month, you're going to get one more percent, 1% more. The thing is, for the second month, you get the interest from the principal amount plus the interest that you earned for the first month. So you get a little bit more. You get a little bit more. So forth and so on. So hopefully at the end of the year, you get more money. And that's what we call the compound interest formula. And the formula is this. The future amount after the time t is equal to P times 1 plus R over N raised to the power of N times T. And let me box that and then I'll explain it to you. In here, of course, P is the principal amount. Okay? R is the rate as we have before. And T, of course, is the time that we had before. The rate is the annual rate. The time is going to be until a year. And, of course, N is the number of times the interest compounded per year. The numbers of times interest compounded per year. So in the example that I just gave you right here, if I want to compound it monthly, I want to have 1% per month, then total in 1 year, I have the interest compounded 12 times because there are 12 months in a year. If N is equal to 12. If I don't want monthly, I want weekly. I want to have the interest every week. Then N will be 52 because there are 52 weeks a year. If I want to compound the interest daily, then N is equal to 365. Some use 360, make it even. 365 or 360, using those numbers are what people are using right now. Okay, and AT we talked already, this is a future amount. Okay, so apply to this formula. If the interest is compounded monthly with N is equal to 12, then I claim you guys are going to have more money. The amount of money after 3 years, so let me pick 3 right here, it's going to be equal to 1,000 times 1 plus interest rate 0.12 divided by 12. You see why we have 1% right here? 12% a year, but we do math, we convert it back to decimal with 0.12 divided by 12 months, it's 1% a year. Okay, and N here is 12 times 3, right? 12 months a year, N is 12, and then times 3 years. And let me get a calculator and then I'll get that number for you. Okay. Right, calculator, turn it on. See, we have 1,000 times 1 plus 0.12 divided by 12, close the parenthesis, and then raised to the power of 12 times 3 is 36. Okay. 1,430 and some cent. 1,430.768, so 7.7. Okay? So if interest is compounded using the simple interest formula after 3 years, you have A3 is equal to $1,360, which is $120 a month. But if you compound it monthly means what? Instead of waiting till the end of the year to get the interest one time, and then the interest is calculated just based on the principal amount without adding the interest into it, you only get that much money. But if you convert it monthly, this is how much you get after 3 years. So let's see what. You get more money actually if the interest is compounded periodically. Means what? You add the interest to the principal amount to get more interest. That was the idea. Okay? And let's check this out. What if I want to compound the interest more often? Instead of waiting till the end of the month, I want to get the interest weekly. N equal to 52. You change the formula right here, and this is 52. And this is 52. And I claim that you're going to have a bigger number. Let's work it out. My calculator. 1,000 times 1 plus 0.12, now divided by 52, and then raised to the power of 52 times 3. 52 times 3 is 156, I think. $1,432.73. You see that you get a little bit more? $2 more. About that. Okay? So, of course, you get more money, which is better. And people tend to get to be greedy, right? Tend to be getting greedier and greedier. Well, $1 more is better. $2 more is better than nothing. Well, why not? So, if you want to get more money instead of compounded weekly, you can do it daily. Try N equal to 365. You get more money. Okay? And we don't stop right there. What if we want more money? And what is the best formula that we have? It's something called if the interest is compounded continuously. Means what? You don't even want to wait for like 1 second to get the interest. You're going to get the interest like right away, after a moment. So we have the third formula, interest compounded continuously. How about, let me write this way, continuous interest. Find the right term to say it. Just write the whole thing. I tried to make it short, but interest compounded continuously. Okay, so you don't want to even wait for. You don't even want to wait for 1 second to get the interest. And the formula is this: AT. I think this marker is out of ink, so let me choose a new one. Is equal to P times E raised to the RT. And I don't have to explain those terminology again. P is the principal. E is that what we learned before, the numbers. We've got 2 point, the constant, 2.71828, and R is the rate, T is the time. Okay? So we don't have N in here anymore because we don't want to compound it periodically. We compound it continuously. And let's see what we have out of that. So A3. I'm going to use in the same example right here. Equal to 1,000 times e to the 0.12 times 3. Okay, the rate is still 12%. Now the interest is compounded continuously. Okay, no time waiting to get the interest. 1,000 times, where's my e, my calculator? Oh, e is right here. So second ln is e to the power of 0.12 times 3 is 0.36. The answer is $1,433.33. So before it was $32, now 33. So you gain about $1 more. Yeah, it's better, but I claim this is the best that you have if you fix the interest rate of 12% and the time is 3 years. Then you won't be able to get any more than this. Okay. So to want to get a bigger amount of money, you have to change the other variable. You change the time, invest a longer time. Okay. Or change the principal amount, put more money in, and you come out with a bigger future amount. But this is the best, given $1,000, the interest rate of 12% annually, with the time limit 3 years, and this is the biggest amount coming out. Okay. So this is the three main formulas. Oh, I forgot to box this, so let me box this one. You see in this section, say what? You have some principal amount. This is the original amount of money you want to invest with that rate, and with the amount of time, the simple interest is gonna just simply multiply the three amounts together. You get the interest, and then you want to find a future amount. Take the interest after the principal. You have the future amount, and that was the beginning of everything. And we come up to a more complicated formula called the compound interest formula. So if the interest is compounded periodically, so n times a year, then use this formula. Okay, you see the problem later on in the homework. You say the interest is compounded monthly, daily, weekly. What about something like semi-annually in half a year? So n equal to 2. Quarterly, n gonna be equal to 4 because you're gonna get the interest every 3 months. Okay. And then what? A monthly, weekly, daily. So you can figure that number n out. Here comes the best formulas to get the interest, so that you can get the best future amount. The biggest future amount is if the interest is compounded continuously. All right, you have this. There is one more formula that you see in the book and our textbook. They talk about something called the effective rate. Effective. Put it number 4 then. Effective rate. Make it short and easy for you guys to understand. Effective rate is this. You don't even care, you don't even know how they invest your money. All you care is this. If I give you $1, okay? And after 1 year, so T now is 1 year, T 1 year, so T equal to 1. Then how much you give me? The difference is gonna be the effective rate. So if you give me $1, after 1 year, I give you back $1 and say 20 cents. No, 20 is too even, so 20 cents is good. How about $1 and 7 cents? Make it more practical, okay? So what is the difference? The difference is 7 cents, right? $0.07. 7 cents. This is the effective rate. 7%. $1 in, $1 and 7 cents out after 1 year. The time is restricted to 1 year. Okay? Then the rate is 7%. Because you see that, right? 1 in and then 107 out. So 7 out of 100, 7%. So in general, the effective rate formula is this. The rate with the E down here, effective rate, is the future amount, subtract the principal amount divided by the principal amount. Okay? This is how much you get at the beginning, right? And this is how much the future amount you get at the end. You calculate the difference divided by the original amount of money that you have. It's going to give you the effective rate. Okay? And of course, in this formula right here, we don't know, we don't care how they calculate the interest, what is your actual rate is. You only care what the difference between the output and the input relatively to the principal amount. Okay? And of course, you simplify, this is like A over P minus 1. Okay? So if interest is compounded periodically, the RE is going to be what? A over P is going to be 1 plus R over N. Oh, N is, I think N is 1 already, right? 1 year. So 1 plus R. Oh, N is 1 year already, raised to the T power minus 1. If the interest compounded continuously, then RE is equal to, oh, N is N times a year, yes, so we still have an R right here. So R over N raised to the N power, T is 1 year, so I don't have to write T. And this is E to the R times T is 1, and then minus 1. Okay. This continues. Okay. And that's you have this formula right here. One more time, effective rate is all you care. You look at what the initial amount and the I'm talking about the final amount. See what the difference. That's all. Okay. And people use $1 because you see in here, it's you $1 and then you divide by 1. You don't have to division. But in general, all you do is what? you take your final amount, subtract the principal amount, the original amount, divide by the original amount. The difference between the ending point and the beginning divided by the beginning. Then you have the effective rate. Okay. So say I got 1,000 for now. Okay, and I invest into 1 year. 1 year. 1 year. Okay, and I come up with 1,000 and say $35. Okay, after 1 year. See, I don't care how you do with my money. I threw in $1,000, and a year later I get back $1,035. Then I can calculate my effective rate. All I do is what? Take $1,035, subtract $1,000. That's the difference I get after 1 year, which is the interest, and in 1 year, okay, divided by 1,000. So this is 35 out of 1,000, which is 3.5%. Okay, so I know that I will get 3.5% more with whatever the amount I get. I give it to you, and then you, the bank, and some investor, and then that's what I get back. And that's the meaning, the idea of the effective rate. Okay, again, you have the formula, depends on the type problem. You just look in the numbers, you have the answer. Okay, but I tried to tell you a little bit more of that. It's the meaning of it, the difference between the final amount with the initial amount divided by your initial amount. That's the effective rate. In 1 year, of course. Okay, so let's try some exercises in this section. I have a copy of some problems in front of me, so let me try some. Okay. How much money you need to get $100 after to get $1,500 after 1.5 years? Okay, so they give you this. The time is 2.5 years. Of course, you have to convert it back to decimal, which is 2.5 years. Okay, and the rate is 1.5%, 1.5%. Then you have to change it back to decimal, 0.015. Okay, and the question is this: if I need $1,500, I want that much money after 2.5 years. How much do I need to invest for now with the rate of 1.5% to get up to $1,500 in 2.5 years? So they give you this one, which is the future amount. Okay, and they ask you for P. How much do I need for now? So that 2.5 years later, I'll get $1,500, 1,500. If I invest in some kind of investment with the rate of 1.5%, and of course the time is 2.5 years, 2.5 years. So you have what? Plug the formulas is. They have to look for one thing. How does the money is compounded? It's compounded. Let me see in here. Compounded daily. Compounded daily. This is a method of investment. Means what? N is equal to 365. Okay. So you know the formula we're gonna use. The interest is compounded daily. So we're gonna use compound interest formula. We know that AT is equal to P times 1 plus R over N raised to the power of N times C. See what we know? After 2.5 years, you got $1,500. What you don't know is the P right now, so I'm gonna write right here. And this is 1, I know. So R is 0.015. Let's give you compounded daily, so N is 365. Okay, raised to the power of 365 times 2.5. Okay, 2.5 years. So I got all numbers except for P, so I can calculate P in here. Just plug in your calculator and calculate P. Okay, I'll get that work for you. That's one type of problem. Let's see another one. You see this. I see it's another problem. Say what? What is the actual rate of interest compounded quarterly if the effective rate is 7%? the effective rate equal to 7%. Okay? What is the actual rate? And they give you one more information, one more piece of information. What did they say? A compounded quarterly. Quarterly means n compounded quarterly. A quarterly means what? N is equal to 4. Okay, so every 3 months, a quarter, you get some interest. It's compounded quarterly. Okay, so I know that I have to use the